guys. My name is Nick Fett. I am the CTO of Tellor. Tellor is a decentralized oracle on Ethereum. Basically, what we do is we provide price feeds for smart contracts. So if you need the Bitcoin price, the Ethereum price, or some off-chain price, we're the people that you want to contact if you actually want the price on there in a decentralized way. So a little bit about my background. So crypto-wise, I've been in the space for a while. I'm actually an economist by training. So I worked for the US government actually for a while. Namely, I worked on the unemployment numbers originally, and then I moved over to help at the CFTC. So I was a researcher there. CFTC, they actually regulate derivatives and cryptocurrencies. So I was on kind of the regulatory side, and then I left in mid-2017 to start up Daxia, which was a decentralized derivatives protocol. So we were basically building out futures and options style contracts on top of Ethereum. We got an Ethereum Foundation grant for that, which we used to kind of study oracles. So if you're trying to build a contract, basically a futures or an options contract is it's a financial contract where you're betting on the price of something. So you're betting whether or not the price of Bitcoin is going to go up or go down. And you really run headfirst into the problem of how does your smart contract know what the price of Bitcoin is or what the price of Ethereum is. And that's called the oracle problem in the space, because there's actually no ability for Ethereum smart contracts to read off-chain data. So they can't go hit up the Coinbase API. Somebody actually manually has to enter that. And we saw that as a big problem that, few people were, we thought, trying to tackle it in a way that made sense for what we were trying to do. So we created Tellor, which is a protocol that puts prices on chain. So you guys can go look up Tellor. I'm going to assume if you're trying to implement it, you know a little bit about the background of what it is and the needs. But basically, if you're trying to put a price on chain, or you have to manually enter a price, that's a centralized point of failure. You want some way or somebody else to do that. And the way that Tellor works is we have a network of, they're staked miners. So they compete at a proof of work challenge to go and get the Bitcoin price or whatever price you need and put it on chain for you. So it's sort of this gamified version that allows you to trustlessly get this price and nobody can censor it. But today, what I'm going to do is I'm going to show you guys how to actually implement Tellor into your smart contract. It's going to be a real simple implementation, but hopefully you guys can kind of get the gist of it. I'm going to use a truffle project. Truffle is kind of like just an Ethereum dev tool, and then hopefully we can get all the way up to doing some local tests on it. It's really simple. I ran through it last night and it took me like 10 minutes, but it'll probably take me like 20. So I know trying to do these things in real time is always much more fun. So anyway, okay. So can you guys see my screen? Yes. Okay. I got a head nod. Yeah. Okay. So we're going to create a, what should we call our project? Devfolio. We'll create a project, and then what you can do is you can just do a truffle init, create a truffle project in there. And now we'll go and we'll open it. Devfolio. Here it is. So this is our new base solidity package. And now this is the fun, the magic with Tellor. What you're just going to run is you're going to run an npm install using Tellor. So kind of get you the meat of it. That might take a while. So as you guys know, with npm installs, sometimes they can do it. So what we're actually going to do is we're going to go look at what contract we want to do. So we actually have in our GitHub, so github.com/Tellor-IO, you can come and there's a sample using Tellor contract. So this shows you how to read prices. And we're going to click on this if it wants to load. The other thing, so we're actually just walking through the documents. So like I'm manually typing it, but if you go here to user contracts, this has it all laid out. So right here, this is just what I'm walking through. Now we're on the npm install, and here's the sample repo. So it's not everything's documented. We try and make it really easy. So I've done plenty of hackathons in the past, and trying to integrate a project and get it tested locally. You spend like the entire time just trying to figure it out, and that we'd rather you guys do other things and you don't have to think about this. So what we're going to do is we're going to come into the contracts and we're just going to cut and paste the sample using Tellor, and I'll kind of walk through what it actually does. So here is our folio piece. We'll make a new file, and then we'll call it devfolio.sol. And then, okay, so now I'm going to actually talk you guys through some of these pieces. So hopefully, if I'm going too fast or anything like that, just slow me down and let me know. So the first thing you're going to want to do is import using Tellor. So since it's going to be in your node modules file, you can just put import using Tellor / contracts using Tellor. So that'll import the using Tellor solidity file. And then what you can say is your contract is using Tellor. So using Tellor, this is another contract. This is solidity for basically take this using Tellor contract and just paste all the functions on the bottom. It just gives you access to all of those functions. And so it's a really simple way to add another contract's functions. In the constructor arguments, though, using Tellor takes an argument. It needs to know the Tellor address. So like where your, like if you're on mainnet, you would put in our mainnet contract address. Because obviously if it's reading prices from that Tellor contract, it needs to know where it is. So it's a weird sort of solidity format. I haven't seen many other places, but you would pass in the Tellor address here and then specify that it goes to the using Tellor contract. The other thing that you need, if you're reading prices from Tellor, you need to know the Tellor ID. So we have those up on, if you look at the documentation, there's a link to an Excel file with all of them. Like ID1, if you're on mainnet, is the ETH US dollar price. ID2 is the Bitcoin US dollar price. ID3, I believe, is the BNB price. ID4 is like the Bitcoin price, 24-hour average. So you can go look which one you want specifically for your contract. If you need help, if you're actually trying to build something in production, which kind of Bitcoin price you use is a pretty big importance. So using the current median price versus the 24-hour average price versus some sort of volume weighted metrics. There's different reasons to use different ones. So happy to talk that through with you. So those are the only two things you really need. And then what you're going to do is you have access to mainly 3 different functions. So there's get current value of the Tellor ID. And what that's going to do is it's going to return back a Boolean value, mainly did it go and get it, yes or no. You can run any checks in your system, make sure it came back, the current value, and then also the timestamp. So you can check like, hey, maybe this price hasn't been updated for 2 weeks. You probably won't want to use that. Or make sure that it's within a day. And then get data before. So this one also goes and gets the current value, but you might want to delay it. So the reason you might want to delay it is because the way that the Tellor system works is people put a price up on chain. So we'll say like we have 5 different miners who get to mine on, let's say, the Bitcoin US dollar price. They'll all submit solutions, and we take the median as the official value. If the problem, let's say those 5 miners are all malicious, they're all together. What'll actually happen is, let's say they say the Bitcoin price is $1 million. They'll submit it, and it'll be available to read instantly, but you might not want it because somebody else, you can dispute that value. So you can say, hey, the Bitcoin price isn't $1 million. It's actually, closer to 9,000. And then those miners would get slashed. So that value would get taken off chain and they would get slashed. How long you want to wait is kind of up to your comfort level. So this is similar to like, if whenever you like deposit Bitcoin on Coinbase, you have to wait an hour before you actually have access to it, because you have to wait for all of the, the block confirmations to go through, and that you're not being malicious. So you want to make sure that you give it some time. If you have a script running on the side, that you can just wait 10 minutes or something, checking these values. But just to be safe, these are the 2 different ones. Anyway, it also returns the same things. And so yeah, those are the 2 different functions that you have. But for our little project here, we'll write a new function. We'll say test values, and it's going to extends, and we're going to return a Boolean. And we're going to say, first what we're going to do is we're going to update values, and then if we'll just say like if current value is greater than 100, return true, else return false. And you can, like what this would be in your, let's say you were creating a derivatives contract or a stable coin, you could say like, you could check if your contract is collateralized based upon the ETH US dollar price. A sample derivatives project.
Yeah, Nick, I don't think we can hear you.
Yeah, the screen has frozen.
Okay. By the way, Sunny, can you mute your mic?
Yeah, sorry.
Sorry, I logged off.
Hey,
Whoa,
no problem. No problem. It's all good. Yeah. So I think you can continue. Yeah.
I guess I have to share my screen again. Okay. Did you guys see me making the test values?
I know, I think we missed that. So we just go through this last function.
Cool. Okay, so we have that last function up. Now what we're going to do is we're going to compile it. So we'll see if we have any errors here. All right, that was successful. Woohoo! So there's 2 things that you really need with a project. So you're going to want to know how to migrate the project and then how to test it. These are things that most projects don't really give you in the documentation. And I know because I've done my fair share of hackathons. So you want to make sure that you know how to migrate these things and how you know how to test it. So what we're going to do, Tellor, we have not made the same mistake. So here is a Tellor migrations file. And we're just going to cut and paste it because I'll show you guys how it works. So we'll come back over to our DevFolio project. And then we're going to make a new migrations file. And then we'll save it as Tellor migration. Okay. Forgot to add the .js. And then it's not going to be pretty unless I click it. Anyway, okay. So whenever you're migrating for actual use, say on Rinkeby, you don't need to deploy a sample Tellor. You don't need to deploy a mock Tellor contract. There's already a Tellor contract deployed on Rinkeby or on mainnet, so you can just paste in the address here, and you can use that one. If you're trying to locally test it, though, you need to deploy, we actually have a mock Tellor system that's built into the using Tellor package. So you need to deploy kind of like a pretend Tellor, so that way you can enter a value in. And that's what these things are that are commented up here. So you can just come here and uncomment this. And then we'll comment this piece out at the bottom. Down here. And then there's one piece that you're going to want to change. So our contract is not called sample using Tellor. We changed it to DevFolio. So I'm just going to change this stuff really quick. And then down here, so it'll automatically just deploy. It's this gigantic piece. So like the way Tellor deploys, there's a whole bunch of library contracts, and it's a rather complex system, just due to kind of Ethereum gas limits as far as contract size go. But you don't need to know anything of that. You just need to know that down here, we're putting in deploy the DevFolio contract. This is the request ID. So, you know, we're just going to use one in our mock Tellor system. So we get to enter whatever the value wants, and then it's going to grab the Tellor master address. So the new Tellor address, you know, on our local system. So that should be all we need to do here. Since I did the truffle init package, I know this from practice. You have to comment out your network. So we'll run up here, we'll start up another server, we'll run Ganache. So this is starting up a mock Ethereum client, and then we're gonna run truffle migrate here. All right, and it's humming. So now it's deploying all of the Tellor pieces first, and then at the end it deployed the DevFolio contract. So yeah, it rocks. So now we have our contract up, and now we can test it. As far as testing goes, so we'll head back to sample using Tellor, and I'll show you guys just a test file. So this is cut and paste it in, and then we'll bring it back up here. So create a new test, save it as test devfolio.js. Okay. So these are the base, these are the thing. This is using the JavaScript Mocha tests that Truffle uses. If you guys have ever seen this, it's a nice way. And we're going to write a new test. I'll just cut and paste this part. So test devfolio piece. So we're just going to test that we can get it to print true and false. Kind of like our contract. So we have test values. We're going to test initially that it returns false, and then we'll make the current value above 100, and we'll get it to return true. So first thing we have to do obviously sample using Tellor is not sample using Tellor anymore. It's Devfolio. So we'll replace that. And then down here, and then just for name, Devfolio. Sample using Tellor, Devfolio. I'm just going to replace all. Okay. Now we're going to write our first assert function. We're going to assert that you do an await Devfolio dot test values, and then it's a function, but you can put dot call. That's how you in the Ethereum contract. So like if you don't put dot call, it's going to return back like the transaction hash and transaction details. If you put dot call, it'll give you the return value. And we're going to make sure that equals false. Should be false. And now what we have to do is we have to go to Tellor and we have to mine a value. That is this piece here. So it's going to loop through and have our 5 miners mine a value. So we're going to scroll over and you can see here. So it's going to be ID 1. But we need, what value do we want it to be? So we'll say 102 is going to be our value. It's just going to submit 102 5 times. So the median should be 102. And now what we're going to do is we're going to assert await Devfolio test values. Call equals true. Should be true. All right, and now not paying for it. Now the moment of truth. We'll see if testing live actually works. So here we go. And then, all right, so the first one came back. Oh man, cannot read property of call of undefined. So what did we do? So, man. Let's see where it broke. So it broke on line 52. Devfolio test values. So we actually have a problem here. I see this should be public because we run update values. So that, don't know how that worked. Yeah. Let's see my other repo. Yeah, okay, so we'll see if that baby works. If not, you guys are just gonna have to believe me. Don't want to sit here too long trying to, but because I had it working in the other one. So, but if nothing broke, it was there you go. So yeah, we got it to work, which was super cool. So what this did, we created a contract, and then we went and we mined that value. So our mock Tellor contract said, hey, the new value, so it would set the current value at 102. Then we updated the values. It went and updated, put current value equal to 102. And then whenever we called test values again, it returned true. So you guys can use this to basically, you can create any sort of derivative contract that needs a price. Now you have a way to do so and test it without a central intermediary. So I guess the next piece would be, now that it was like right on a half hour, which was my goal. Well, are there any questions or anything else that I can kind of go over on this before you guys kick me off? No.
Sir, I had a question, but it's not related to contracts or something. It's just a generic question.
And I love generic questions. Ask away.
Yeah. So I have two questions for you. The first question is blockchain only for crypto currency transactions, or it can be used for something else also?
Yeah, so blockchains, it can definitely be used for other things besides just cryptocurrency transactions, but there's a few reasons that, so like I'm a big fan of blockchains in pieces where it needs to be censorship resistant. So like blockchains are really, really slow and sort of inefficient at the moment. Like even the best of ones, you're going to get so much better speed and security just from a standard database. The only reason you would really use a blockchain would be is that you kind of want, you definitely want something that nobody can shut down. And as far as value transfers go, you know, usually if it's a real world good, like that's sort of been the big issue right now, kind of over the past few years, is, you know, you heard all of these things where, oh, blockchain is going to be used for supply chains and all of these healthcare pieces. But the problem is that those are tied to real world things. So like if it's tied to a real world thing, it's really hard to sort of put on a blockchain, because the blockchain can't enforce that real world thing does anything. It's, you know, there's sort of a break in it, and it's sort of, you need to, whenever you're talking about what should be on a blockchain, it should be almost these digital assets, these we call them bearer assets. So like where if you transfer it on the blockchain, the transfer actually happens. There's not like, you know, if you transfer the deed to a house on a blockchain, you know, if the US military says you don't own that house, you don't own that house. Okay. So, you know, it's always, there's always limitations to it. So you have to kind of think about it. But I really like, you know, having just the ability to create these censorship resistant pieces that sort of supersede any of the governments or things like that, because you can't shut them down. So yes. Yeah, I don't know if that's a good answer or not. But yeah, it's definitely going to be, you know,
actually I'm more interested
you saw a whole lot of,
sorry.
Yeah, no, go for it.
Yeah, so I was actually more interested in, I'm not actually interested in all the transaction stuff, but how to use blockchaining in, how to use blockchain as networks that are right now here, like YouTube, as a streaming network or a broadcasting channel. So is there a future for blockchain in those particular fields?
Definitely. Yeah, I think, like, you know, the big problem with it in those fields is that, like, you know, anytime you have a decentralized network, like you've shown with currencies or something like that, it's like slower and less efficient. So, you know, like, would people be okay with a YouTube that's slower and worse? And that's going to be kind of the question. And I think there definitely is a future. Like, you know, one, look at like Tor networks. So like you see, you know, like LimeWire or Pirate Bay or all of those like illegal channels for downloading music, for instance. They sort of have a market fit, and they do a whole lot for the community, but they haven't overtaken mainstream music. They haven't overtaken anything. But to be honest, I like it that way better, because it's sort of like, if mainstream music ever tries to charge like monopoly rents or something like that, then we'll all just be back to illegally downloading music really quickly. So it like puts a check on any of the powers that be. And that's what I hope, you know, even if we have Bitcoin and we have a functioning monetary system, or, you know, or a YouTube, like if you have a YouTube that's censorship resistant, it makes the real YouTube better, because they know that people are going to go there if they start censoring people. So yeah, and unfortunately it's like we might not get to the point where we overtake these systems, but we're just sort of the benevolent check on the systems.
Okay.
So I can stop sharing. Anything else, guys? Any other projects? So I mean, if anybody's working on a DeFi project, or if you have an idea, so for a DEX or anything like that, happy to kind of look at it and give you any sort of topics. And we did get a question in the chat. Somebody asked, discuss use cases, but I think that was it. So like use cases for Tellor. So the big ones that we were sort of built for, obviously we originally were building this for a derivatives project, but derivatives is a really big term. So you can think of any sort of lending protocol, any stable coin, any financial product that needs a price feed. That would be something that would be kind of an ideal use for. We love people coming up with some creative ideas too. So if you know of something that is if you can think of some really creative piece. Usually, most of Ethereum right now is sort of just escrow contracts with, ways to release money or bet on top of things. So we're sort of fit for those purposes. Yeah, I think with decentralized oracles, that we're still waiting for really good and really secure stable coins on top of a lot of these networks. And then we're also waiting for even just derivatives protocols. I think that, people are trying to solve it and then also solve it in terms of getting liquidity. So there's a lot of different ideas as, with automated market makers and pieces like that, some of which can use oracles. So
I have a Tellor related question.
All right. Sorry, what was that?
I have a Tellor related question. So in the documents, I read that if you're deploying it on the Ringbean network, then we have to top up all the value calls with some TRB tokens.
So you shouldn't, so that's like, so the question is always like, how does the Tellor system determine what gets mined next? So you actually have to pay in TRB with what gets mined next. So you would want to tip. So obviously, if you're on Rinkeby though, like you can just submit a 0 tip, so you don't actually need any TRB, and that should go through just fine. But also, if you're on mainnet or on Rinkeby and you need some test TRB just to play around with it, just let me know and I'll pass you some, and explain it further. So yeah, like happy to just shoot me an email or reach out to me, and it's just Rinkeby TRB, so I can send you over 1,000 pretty quickly.
So if we use like if the function which we are making for the value calls, if we just make it similar to what you showed today in the demo, so will that work, or do we need to make modifications to send the tokens?
No, so it would work right now. The idea, if you would want to actually request your data, you can, you would have to add a tip to that ID. And the way that you can do that, so you can either write, so we have scripts that are up in the Untitled package, which are in our documentation, or what you can do is kind of on mainnet, we actually just released, share it with you guys. Man, the Zoom piece is in my way. So prices.tellorscan.com. And then you can come here and just add a tip, whether you're on Rinkeby or mainnet. So you can just click whichever one you want, and then it'll go fetch it. And yeah, that might be the easiest way for you to do it if you're actually on one of our networks. So.